Hey guys, welcome to a new video on the Cell Doctor channel. In today's video I'm going to show you how to modify the old Megacell charger, more precisely adding these Mosfet controllers which will improve the resistance of the reverse polarity Mosfets. So at the moment those Mosfets will open gradually depending on the cell voltage that's inserted. So if you have a 3-volt cell, that MOSFET will be partially open and not having the smallest resistance possible. So these LM ICs will keep that MOSFET open, will detect when a new cell is inserted, and fully open that MOSFET. Let me mute this one. So I'm starting by opening the charger. This is one of the testing devices that I use here in the shop to test my cells, and it's the old version and still has this issue. Yeah, so this is the board of the old Megacell charger, and to do this we are going to glue this board on the back of the main PCB. I will be using some double-sided tape. So when you install this, you have written on the board the cell number. So you should have oriented with cell 1 to the right of the board, turned backwards like this. Because when we are going to flip it, we'll have cell 1 in the proper place. So let me remove these. Okay, this is how it looks with the mod applied. You can also use some super glue if you don't have any double-sided tape around, but double-sided tape will make it easier to remove in case you want to do that in the future. Okay, so to do this mod we need to remove these small resistors down here. You can do that by using the hot air gun or a regular soldering iron, because the resistors are so small. If we apply enough heat, it will hit the resistor and desolder it. I'm going to modify 15 ports at first, to have one left to show you what's the difference in terms of voltage drop. I will be applying some solder on both joints, and now the resistor has been removed. It's quite small. I'm not sure if you can see it, but I set my soldering station to 430 degrees, and that will hit the resistor well to remove it. Using this method, sometimes you can have some bridges. Make sure you clean those. You clear the bridges by applying some heat and moving the iron left and right to have the solder removed. Okay, so 15 resistors removed. I left just the one for cell 1, so we are going to measure the voltage drop difference when we connect the charger. Now we can move to the second step, which is connecting the wires required to power the board and also to drive the MOSFETs. I'm going to use the yellow wire for the positive and black wire for negative. So I'm going to make this length of wire. And to make things a bit faster, I can actually do this step at my wire cutting machine. The nice part of this wire cutter is that it also strips the wire as well. I'm using this to create the connectors for the Megacell charger. So let me check the length of the wire that we have to cut. Now that I got my wires, I can proceed to connect them. But I'm going to use a small alligator clamp to hold the wire while I'm applying some solder. So each end must be tinned with solder so they solder properly. To do this process even faster, you can use one of these. It will take a few minutes to get it up to temperature, but after you do that, it will be simpler to tin your wires. Until that's hot enough, I'm going to tin the pads with solder right here. The positive wire for the cell will be connected to one of these pads on the back. So I'm going to apply some solder on each joint. To get our VCC and ground to power the units, we can get that from the display. So the first pin on the right here is the ground, and the one in the middle it's the VCC. You need to make sure they are not shorted like I just did right now. Okay. Sometimes applying some flux when you have this kind of bridge, it will make the solder go on the actual pad and don't be bridged anymore. I can start soldering the wires like this. There is no current that's driven through these wires, so if you have thinner wires that you want to use for the signal, you can use those as well. I just used what I have. The solder bath is also hot enough. Let me turn it down a little, or carefully move it in the frame, and I can remove the oxide that's created on the top. Alright, so to make the solder stick, we need to use some flux on the wires. I usually put it in some container. Let me bring my wires here. Take a few wires, dip them in flux, and they are tinned. Okay, so all my wires are prepared now. I'll push this over to let it cool down. Then I'll move it to some other place. Okay, so I will continue adding the rest of the positive wires. Like I said before, this is not driving any current through the wire. It's just for signaling that there's voltage present at the cell. So this is how it looks with the first part of the wires added. Like I said, I left the cell 1 unconnected for now. I will continue with the gate wires. The gate wire must be connected. Let me see if I can zoom in. You can see these traces from the cell up. It goes here, and the one on the left right here, it's the pad that goes to the gate of the MOSFET. Right here. So we have to solder the wire to this end right here. I'm going to solder one and show it. So this is how it should be. On the PCB you can see cell to G. That's from gate, and this is where it needs to connect. That will be the same for the other cells as well. So I'm going to continue doing this. Okay, so all the gate wires are also connected now. Now I'm left to connect these wires and the mod is completed. So I will start with the 3.3 volts wire, then move to the ground, and then 5 volts. The 5 volts will be connected directly to the power supply port right here. Let's see which one is the positive. This one. So this is going to be connected to the 5 volts. Okay, the mode is now completed. I will just have to do the cell number 1 after we finish the testing. I'm using the 5 volts power supply to power on the Megacell charger, and we then can test the new modification that we just did. Okay, so I connected the new device and I'm going to add its IP right here. And to see if the device works properly, I'm going to insert a cell, and the cell is detected properly. I may actually change the communications type. One thing that Martin added a while ago was the ability to communicate faster with the devices. So to do that, you go to edit settings and change from JSON to binary UDP. If you have firewall on, you might have to add that port to your ports, but usually when Megacell monitor is installed, it's asking for permission. So right now you see that it's updating much faster than with JSON. With JSON it does an update every 10 seconds. This one does it every second or every half second. Okay, so to test that the reverse polarity also works, going to place the cell in reverse, and you see that it shows a really low voltage, 0.188. At this voltage the MOSFET is not opening, so there is no issue. You see that without the MOSFET controller, the voltage it's 1.3 volts. So with the MOSFET controller it's not opening at all, because the LMIC is checking the voltage. If the voltage it's under 0.7 volts, the MOSFET will not be open. So placing the cell in the proper way will show the proper voltage as well. So to test the voltage drop that we get from that MOSFET, I'm going to place which one is more charged. This one I'm going to place it first on the slot number 1, send it a discharge command. So discharging with 1 amp and touching the negative side of the cell and the ground wire, we get a voltage drop of 0.017 volts. I'm going to place the same cell on the second slot, discharge it, and now we can see the voltage drop that we get with the MOSFET driver. So the voltage drop right now it's 0.015 volts, but the main thing is that it will stay at 0.015 no matter what voltage you get on the cell. If the cell is at 3 volts, the MOSFET will not properly open, so it will not fully open to keep this resistance right here. So let's plug in this cell. This is a 3 volt cell, 3.1 volt cell, and if I will hit the discharge, you see that the voltage drop right here increased to 0.02. So this creates a non-linear resistance on that MOSFET, and that's very hard to compensate for when you're doing all sorts of operation on the cell, especially when you do ESR. If you want to do proper ESR reading, you need to know the resistance of that MOSFET to avoid false reading. So for charging it's not a big difference, because the voltage from the charging IC will saturate the MOSFET as well. But we were more interested in fixing the issue for the discharging side, because that MOSFET gets quite hot when you discharge the cell and it's not properly open, especially if you are at 3 volts. And for the new Megacell charger I wanted to have a wider range of cells supported, and that included lithium phosphate and LTO cells as well, and they are operating at about 2.7 to 3.7 3.65, something like this for lithium phosphate, and that caused some issues. On lithium ion cells, you can see that if it's at 4.2 volts, that MOSFET will be like 95% open compared to the 5 volts that we're inputting now. So that's not a big issue, but the main thing is when you start lowering the voltage and you want to have a proper reading on the ESR that will cause some issues. It's not a big thing, that's why we did not catch it in the first place. But if you want to get that additional grade of accuracy, that's what it needs to be done to control the MOSFET. You can do this mod or not, that will depend on your needs, and if you have the time or the money that it will cost to ship this thing to you or to order it directly on JLC PCB like I stated in the previous video. So I found this one working on the professional Megacell charger. I thought it would be a good thing to create a mod for the old devices as well, for those that had this issue. And yeah, that's about it. I hope you enjoyed this video. Stay tuned to this channel. If you're not already subscribed, please click the subscribe now button and turn on the notification bell, because I will be adding new videos about batteries and also about the Megacell charger, because there are a ton of new features that have been implemented in the new version of the Megacell charger, the professional version. There's the metal case design that's very versatile for different style of cells, and I've been adding a lot of new features like external temperature sensors, additional voltage reading, so we match the 4-wire voltage reading that you will get, and the list goes on. I've been working for the last 3 months solo on this project, like the Megacell charger is the main focus, so I've been working on the hardware, finished the hardware, and started the firmware for the project. Total revamp, a lot of new things have been redesigned, and the full state machine workflow that have been implemented, it's making a big difference in terms of not being in a state that you should not be when you're measuring cells, because sometimes if you would remove a cell fast enough, place it back, it can trigger some issues. So having a state machine that controls this, it's going to make this process much safer in the future. We have additional temperature sensor for the charging IC. The charging IC supports multiple current settings and also different charging voltage settings, so it will adjust the charging curve depending on the set voltage that you want to add. So ton new features. I hope you will find this useful. I already find those very useful in testing my big 50 amp battery, and I will make some videos showing that process as well, how to connect the accessories, how to make everything work, and how to set up. I'm also working on a new menu. The reset button will become a function button as well, so you'll have 2 buttons right here. I'm going to place another reset button next to this one, but a small hole will have to be drilled through the case to access that button. So that's about it for today, guys. If you have any questions, don't hesitate to go on deepcyclepower.com, write on the chat or to the email, or open a ticket if you have a support issue. If you have more questions about this mod, you can comment on this video and I will reply to them as fast as I can. Thank you very much again, guys, and I wish you a great day. Alex.